In this video, we are going to go over converting rates using something I call the table method. Let's begin. When we go over examples, this information chart will be super helpful for us. It gives us conversions for US customary units, metric units, and also a conversion chart for US customary units to metric units. Now, before we begin some examples, we want to review the idea of canceling terms or just multiplying fractions, because a lot of these ideas are going to be involved with the table method. So we have 7 over 2 times 8 over 7. And how do we normally solve this? Or how do we normally simplify this? Well, when you multiply fractions, you just multiply the top numbers, 7 times 8. And that's going to get you 56. And then you multiply the bottom numbers, which is 2 times 7, which is 14. So 56 over 14. Now, what I often do is before I multiply the numbers, it's a good idea to cross-cancel or reduce. Now, cross-canceling or reducing means that you can take this number right here, 7, and then you can reduce it. You can see if you can reduce it with a number beneath it. Now, in this case, I can't, because there's nothing that goes into both 7 and 2 except for 1. Cross-canceling is when you reduce it using the number diagonal from it. So 7 and 7, they are diagonal from each other. Can they be reduced? Yes, I can divide them both by 7. And when they are the same number, we often call it canceling. Your teachers will often say, oh, you're canceling the 7. But what we really mean by that is that you're dividing it by itself and it gets replaced by 1. So why do we call it canceling? And let's pretend for a moment that we don't know that we can reduce or cross-cancel 2 and 8. Let's just pretend. So why do we call it canceling? Well, because on top, all you're left with is 1 times 8, which is 8, and then 2 times 1, which is 2. So it's almost like we canceled the 7. It's almost like it doesn't exist, and all you're left with is 8 over 2. So from here, we're not done yet. What do we do with the number on top and below? It's an improper fraction. Well, you do division. 8 over 2 is a division problem. It's essentially 8 divided by 2, because remember, fractions are division problems. So 8 divided by 2, if we simplify that, is 4. So remember all those elements. When you multiply fractions, you multiply the numbers directly across from each other, horizontal from each other. You can cancel or cross-cancel terms if they are the same. And also at the very end, when we reduce, or when numbers are on top of each other, we divide, because it's a division problem. So let's get to the meat of our lesson today. A rate. Well, a rate is a comparison of 2 different kinds of units. Examples of rates include these. Gabriel can run 8 miles per hour. So what are the 2 units? Well, miles, which is measuring distance, and hours, which is measuring time. So this is a rate because you're comparing 2 different units. Bananas cost $1 per pound. Well, what are the 2 things being compared? Well, the cost per pound. And let's look at another one. There are 320 calories per serving, and those are the 2 units we are comparing. How many calories versus how many servings of ice cream. Rates can be written in different ways. For example, 8 miles per hour can often be written out in these ways. 8 mph, which is miles per hour. You also see it written this way, 8 miles / hours. And the slash is like a fraction bar, and the fraction bar means per. So 8 miles per hour. You can also see it written like this, 8 miles per hour. Or like this, 8 miles per hour. As you can see, it's like on top. And then finally, 8 miles per hour. Well, 1 hour. Now, why do they put 1 hour? Because hour and 1 hour mean the same thing. So let's try some examples. Directions: convert these rates round to the nearest hundredth if necessary. 8 miles per hour needs to be converted to kilometers per hour. So in these examples, we are just converting one of the units, which in this case, we have miles to kilometers, and then the hours stay the same. So how do we use our table? Well, I start off by drawing my table, and then what I like to do is I like to write down what do I ultimately want my units to be at the end. I want kilometers per hour. So I'm going to write that on the far right side. Now let's write down the information I have so far. We have 8 miles per 1 hour, 8 miles per hour. To continue our table, let's look at our conversion, because We need to know how to get from miles to kilometers. So 1 mile equals 1.6 kilometers. Let's draw a little divider for our table. And what we're going to do is we're going to go from miles to kilometers. And to do that, we're going to put miles on the bottom. And then we're going to put kilometers on top because miles will be converted to kilometers. Now, why would we put miles on the bottom? Well, if we have it miles on top and on the bottom, we can cancel each other out. We can cancel those terms. A mile on top, mile on bottom, that cancels it out. And now we are going to write our conversions. 1 mile is 1.6 kilometers. So if we see what we have left, we have these numbers, and then we have kilometers, which hasn't been crossed out on top, just like we have them here. And we have hours on the bottom, which hasn't been crossed off, and that's down there. So what do we do with these numbers? Well, the numbers across from each other get multiplied. So 8 times 1.6. And on the bottom, 1 gets multiplied with 1. And if you multiply that out, 8 times 1.6 divided by 1 times 1, you end up with 12.8 over 1, which is just 12.8. So 12.8 kilometers per hour is going to be our answer. Number 2, $875 per day. We need to convert it into dollars per week. So let's write down what we ultimately want, which is dollars per week, and write down the information we have, which is $875 per 1 day. Let's look at the day to week conversion. You guys may already know, well, you just multiply it by 7 because there are 7 days in a week. That's true. Now, once we get to more difficult problems, this table will be more handy. But yes, some of the answers are obvious, and we do start off with easy questions so that once we get to more complicated ones, you'll have an idea. Anyways, let's look at the conversion. 7 days in 1 week. Excuse me. 7 days in 1 week. So we draw our separator. We want to cancel out the days and turn it into weeks. So if we want to cancel out days, where do we put it over here? Well, if we have it on the bottom, to cancel it out, we need it on top. So days per week, and we are going to cross out our days. Now let's write the conversion. 7 days in 1 week. So 7 days in 1 week. Now we multiply. 875 times 7, and on the bottom you're multiplying 1 times 1, which you really don't have to do. That equals 875 times 7 divided by 1 divided by 1. You should get $6,125 per week. Let's look at this one. This one gets a little bit more complicated. 35 calories per cup equals how many calories per gallon? So 35 calories per 1 cup. And ultimately, I do want calories per gallon. So how do I get from calories per cup to calories per gallon? Well, calories is good. I'm all set with that. I don't need to change that, but I do need to change the cups to gallon. Where do I do that? That's liquid measures. So cups to gallons. There is no cups to gallons, but there is cups to pints, pints to quarts, and quarts to gallons. So I need to convert these one by one. So this information right here, I'm going to use that. I'm going to get from cups to pints first. So if I want to cancel out the cups and turn it to pints, I put the cups on top, pints on bottom, write the conversion down, 2 cups for 1 pint. No, that's right. I cross it off first. 2 cups for 1 pint. Now I go from pints to quarts. So do another separator. Cancel out the pints. So put it on top. Quarts go on the bottom. Cross that off. Let's write the conversion. 2 pints for 1 quart. 2 pints for 1 quart. And finally, look at what I have here. I have calories per quart right now, but I need calories per gallon. So put quarts on top to cross that out, and then gallons will go beneath it. Let's cross off the quarts. The conversion is 4 quarts to 1 gallon, so 4 quarts to 1 gallon. Now I take all these numbers and then multiply and divide. So what I have is 35 times 2 times 2 times 4. On the bottom, I just have 1 times 1 times 1 times 1. And if you put that in your calculator, 35 times 2 times 2 times 4, divided by 1, divided by 1, divided by 1, divided by 1. Or if you wanted to, you can just do 35 times 2 times 2 times 4, which gets you 560, and 1 times 1 times 1 times 1, which gets you 1, and you end up with 560 divided by 1, which is just 560 calories per gallon. That's our answer. Try both of these in your calculator and see which one works out best for you, or if they both work out. One way you can do it is just multiply these numbers on top, 35 times 2 times 2 times 4. And then just divide it by each number on the bottom. The other thing you may have to do is just multiply it out first, write down your product, and then multiply all the numbers on the bottom. write down the product, and then do the division afterward. So check how your calculator works and, do what works for you. Let's go ahead and why don't you try this one? Take a pause on the video and then replay it or play it once you're done. Anyhow, let's do it. 149 per pound. And we want to change it to price per ounce. So we know that it's 149 per 1 pound. And the cost is good, but we need to change the pounds to ounces. So let's look at our information. We have weight, which is 16 ounces to pounds. So we want to cancel out the pounds, turn it into ounces. We cross off the pounds. Let's write the conversion. 1 pound is 16 ounces. There you go. Now, what do? Well, we just multiply the numbers on top, 149 times 1, and on the bottom we have 1 times 16. So you can do 149 times 1, which you don't really have to do that, and divide it by 1, which again, you don't have to do, and then 16, or just 149 divided by 16 in your calculator. You should get roughly 9 cents. It's going to run a little bit longer, but when you round it, it's going to be about 9 cents per ounce is the cost. Let's take a look at more difficult problems. Now, we're going to be converting rates when both units must be converted. So we have 65 miles per hour, and we're going to turn that into feet per minute. Now, notice miles needs to change to feet, and hours need to get changed per minute. So these start getting really tricky. So make sure you follow along. Pause if you need to. All right, so let's write down the information we have. 65 miles per 1 hour. And ultimately, I want to end up with feet per minute. So I need to change the miles to feet and the hours to minutes. So let's go ahead and change the miles first. And so we have 5280 miles equals, 5280 feet equal 1 mile. So that's a direct conversion. That's kind of nice. To cancel out the miles, I need to put miles on bottom and then feet on top. Let's cross off the miles and then write down the conversion. 5280 feet is 1 mile. All right, now I have feet on top, which is exactly what I want. I need to change the hours right here to minutes. So let's see if we can do an hour to minute conversion. We can. It's a direct conversion. 60 minutes is 1 hour. So we're going to write hours on top so that we can cancel the hours and then minutes on bottom. So cross off the hours and write the conversion. 60 minutes is 1 hour. All right, now we have feet on top, minutes on the bottom. Perfect. Let's deal with our numbers now. 65 times 5280. And you don't really need to write times 1. I'm not going to anymore. And then on the bottom, you have 1, 1, and 60. So write 60 on the bottom. And if you want to try, go ahead and put 65 times 5280 divided by 60 and see if you get the right answer. Or you may have to multiply this out, get the product first, and then divide that by 60. Anyhow, if you did it correctly, you should end up with 5,720 feet per minute. Let's look at example 6, 2 liters per day. And how many gallons per week is that? So we have 2 liters per 1 day, and we ultimately want gallons per week. So let's change the liters to gallons first. Liters to gallons is a direct conversion. 1 gallon is 3.8 liters. So to cancel out the liters, I put the L on the bottom and then gallons on top. Let's cross off that liters and then write the information. 1 gallon is 3.8 liters. Now we have gallons on top, which is what we want. We need to turn the day into weeks. So how do we do days to weeks? Well, the conversion is 7 days equals 1 week. So let's cancel out the day by putting it on top. That lets us cross it off. And then we have week on the bottom. Let's write the information now. 7 days in 1 week. So 7 days in 1 week. Now we have gallons per week. And we just have to deal with the numbers. 2 times 1 times 7, or just 2 times 7. And then on the bottom, we just have 3.8 is the only number that's not 1. You may be able to just do 2 times 7 divided by 3.8, or you may have to multiply that out and go 14 divided by 3.8, which equals 3.68 gallons per week. Let's look at number 7. 20 kilograms per week equals how many pounds per day? So, information I know, 20 kilograms per 1 week. And I ultimately want pounds per day. So pounds per day. Let's convert the kilograms to pounds first. Kilograms to pounds, 1 pound is 0.045 kilograms. So to cancel out the kilograms, I need to put it on the bottom. Pounds go on top. And let's take a look at the conversion. 1 pound is, let's cross that off. 1 pound is 0.45 kilograms. Now that I have the pounds on top, I need to change the week to days. So weeks to days conversion is 7 days in 1 week. So let's write week on top, days on the bottom, cross off the weeks, and we know that 1 week is 7 days. Now, we have pounds per day, which is exactly what we want. Let's deal with our numbers. 20 times 1 times 1, which is just 20, and 1 times 0.45 times 7, which is just 0.45 times 7. If you have a number like this, check to see if you can do this in your calculator. 20 divided by 0.45 and divided by 7, and see if you get the right answer. You may have to do it separately. You may have to do the product of the top first, which is 20, and the product of the bottom, which is 3.15. So see if doing 20 divided by 0.45 divided by 7 is going to get you your answer, which is 6.35. Or you may just have to multiply the bottom out first and do 20 divided by 3.15. See which works for you. I know I've said that again and again, but it's important. All right, we have number 8, which is a challenge, just in case the others weren't challenging enough. 6 meters per second equal how many yards per minute? So let's write down the information. We know 6 meters per 1 second. We ultimately want yards per minute. What makes this so challenging? Well, how do we get from meters to yards? Unfortunately, we don't have meters to yards. We have meters to feet right here. And from there, we can actually go from feet to yards. So what we're going to do is do that. So we do have the meters to feet. So we're going to put meters on the bottom so we can cancel it out. Feet on top. Cross off the meters, right? The conversion. 1 foot is 0.3 meters. And now that we have feet, we need to turn that to yards. So let's look at the conversion. 3 feet to 1 yard. Let's put feet on the bottom, yards on top, and we know that, and cross that off. 1 yard is 3 feet. Now we have yards on top, exactly what we wanted. We need to change the seconds to minutes. How do we do that? Well, let's see, 60 seconds in 1 minute. So if we want to cancel out the seconds, we need to put it on top, and then minute goes on bottom. This crosses out the seconds, and then write the information. 60 seconds is 1 minute. So let's make sure we did this correctly. We only have yards on top, and on bottom we only have minutes. Good. Let's deal with our numbers. We have 6, 1, 1, and 60. The only important numbers are 6 times 60, and the bottom numbers, the only important ones are 0.3 and 3, and then we have 1s left over. So see if you can do 6 times 60 divided by 0.3 divided by 3, or you may have to multiply the top first and then the bottom, and then do division there. Anyhow, once you work all that out, you should get 400 yards per minute as your answer. Whew. Those were tricky, and now we're going to word problems. Now, number 9 and 10 on the word problems are kind of unique. It's a little bit different than what we've been going through because we are trying to figure out a unit, a missing unit, and there's 2 ways to do that. We can do it using the table method, which we've been working on, or we can use a proportion, which is actually the method I prefer, but do whichever one works best for you. The methods can be confused with one another, so be really careful because, well, you'll see. An oil pipe burst, causing oil to spill at a rate of 42 gallons per hour. The pipe was finally repaired after 2.5 hours. How many gallons of oil were spilled? So ultimately, you want to find out how many gallons, not gallons per hour or gallons per minute or gallons per anything, but just gallons. So I have that fraction bar over there just to kind of indicate to you that it needs to be on top, but you don't need to write that bar in your answer. Ultimately, I want to know how many gallons. So how do I set this up? Well, we want to start off with the single unit. And what do we mean by single unit? Well, we have 2 numbers. We have 2.5 hours, and we have 42 gallons per hour. Which one of those has a single unit? Well, 42 gallons per hour is 2 units. It's a rate. It's a gallon per hour. 2.5 hours, that's a single unit. It's not hours per something else. So we start off with 2.5 hours. And then on the other side, we're going to put 42 gallons per hour. Now, how do we don't want hours in our answer. We just want gallons. So we need to cancel out this hours. So you write it on bottom. And then the thing it's compared to is gallons per hour. So gallons on top. And we're going to write down our information. It's 42. Well, let's cross that off. 42 gallons per 1 hour. And then we deal with this. Multiply the top 2 numbers, 2.5 times 42. And then divide it by the bottom, which is 1, and you don't really have to do that. And you end up with 105 gallons is going to be our answer. I prefer to do it as a proportion. So what is a proportion? It's a comparison of 2 different fractions. So I'm I'm going to start off by writing 42 gallons per 1 hour. Now I have some other information. It's 2.5 hours. Now I'm going to put it on the other side, on the other fraction, but where should I put it? Should I put it on the top or on the bottom? Well, it's like the opposite of what you've been doing with the table where you want to cancel. For a ratio, for a proportion, you don't want to cancel. You want to keep things organized. So anything related to the gallons would go on top. Anything related to the hours would go on the bottom because I put hours on bottom. So 2.5 hours, that would go on the bottom. And how many gallons were spilled? Well, I don't know. So I'm going to put an N, which is a variable. It's a mystery number. It's a number I don't know. And from here, we have 42 gallons per 1 hour equals N gallons per 2.5 hours. How do we do this? We do something called cross multiplying. It's not a multiplication symbol in the middle. It is an equal symbol. So we cross multiply. So I always cross multiply the variable first. So it's going to be 1 times N. So 1 times N, which is 1N, and 42 times 2.5. Now let's simplify this. 1 times N is just N. 1 times any number is itself. 42 times 2.5 is 105, and that's the answer we had before. Let's take a look at number 10. Reese can run at a steady rate of 9.4 miles per hour. How many hours will it take for her to run 2.62 miles? So again, we have a rate right here comparing two different things. How many hours will it take? Well, that is the thing we're looking for at the end, is how many hours for her to run 26.2 miles. That's some extra information right there. So we start off with the single unit. Is it 9.4 miles per hour or 26.2 miles? Well, it's obvious. 26.2 miles is a single unit. 9.4 miles per hour is a rate. It's got two things being compared. So I'm going to start off by writing 26.2 miles. And then let's write the other piece of information, 9.4 miles per hour. Well, I want to cancel out the miles and be left with hours. So put miles on the bottom, hours on top, cross off those miles, and then write down the information. 9.4 miles per how many hours? 1 hour. And then now I do 26.2 times 1, which is just 26.2. And then on the bottom is 9.4. So 26.2 divided by 9.4 is roughly 2.79 hours. Again, I would have done a proportion instead. What equals what? We've got 9.4 miles per 1 hour. How many hours will it take for her to run 26.2 miles? Well, miles would go on top or bottom. Well, because it's a proportion, it's a comparison of two things. If I put miles on top there, I need to put it on top over here. And then our missing information is right there. So let's do some cross canceling. 9.4 times N, which is just 9.4N, 1 times 26.2, which is just 26.2. Now we have 9.4 times our mystery number equals 26.2. 9.4 times what equals 24.2? It's a really difficult question. So we're going to do some algebra. We're going to divide. I can figure this out by dividing each side by 9.4. Using division. So remember what we talked about canceling. If I have 9.4 on top of a fraction bar and 1 on the bottom, I can cross it off and cancel it out, which leaves us with N. 26.2 divided by 4 is, 9.4 is 2.79, which is the answer we were looking for. Let's look at 11. The speed limit on a Canadian highway was 75 kilometers per hour. How fast is this in miles per hour? So this is more like what we've been working on before, 75 kilometers per 1 hour. We ultimately want it to be in miles per hour. So we only need to change, the hours are good. We need to change kilometers to miles. So kilometers to miles is right over here. 1 mile equals 1.6 kilometers. So to cancel out kilometers, we put it on the bottom, put miles on top, cross off the kilometers, write the conversion. 1 mile is 1.6 kilometers. And then we multiply our numbers. 75 goes on top, and the only number worth it on the bottom is 1.6 because everything else is just a 1. So 75 divided by 1.6 is 46.88 roughly, and that's going to be our answer. Let's take a look at number 12. The front lawn requires 28 gallons of water per day. How many liters of water does it require after a week? My goodness, let's write out the information we know. 28 gallons of water per 1 day. And we ultimately want to find out liters of water per week. So liters of water per week. So we have to change both the gallons to liters and the days to weeks. So let's do the gallons first. 1 gallon is 3.8 liters. So let's put gallons on the bottom so that we can cross cancel or cancel that out. And then write the conversion. 1 gallon is 3.8 liters. Now we have liters on top. We're good on that. We need to change days to weeks. So the day to week conversion is 7 days in 1 week. So days on top, which allows us to cross it off and cancel it out, and write the conversion, 7 days in 1 week. Now you multiply it out, 28 times 3.8 times 7, and divide it by just 1, which should equal 744.8 liters per week. And finally, our challenge question, the last one here. A car was driving 60 miles per hour. How fast is that in meters per second? So let's write the information we know. 60 miles per 1 hour. We ultimately want it in meters per second. So we need to change miles to meters, hours to seconds. So we don't have miles to meters, but we do have miles to kilometers. So we're going to change it to from miles to kilometers first, and then we're going to go from kilometers to meters. So to change it, we're going to put miles on bottom, kilometers on top, so that we can cancel out the miles. 1.6 kilometers equals 1 mile. Now we're still not done yet. We need to turn kilometers to meters. So let's write the conversion. 1 kilometer is 1,000 meters. So kilometers on the bottom, that allows us to cancel. Meters on top. Cross off kilometers. We have 1,000 meters for 1 kilometer. Now we have meters on top. We're good with that. We need to change the bottom from hours to seconds. So how do we get from hours to seconds? Well, 60 minutes in an hour, and after that we have 60 seconds in 1 minute. So let's start off with hours to minutes first. So to change it, we do 1 hour, so hours to minutes. So if it's on the bottom, you got to put it on top so that we can cancel it out, write the conversion. 1 hour is 60 minutes, and we don't need minutes, we need seconds. So we add another level. We're going to do minutes on top so that we can cross it off, and then seconds on the bottom. So cross off the minutes. We're left with 1 minute is 60 seconds. That's the conversion. Now we have meters on top and seconds on bottom, which is exactly what we wanted. Let's deal with the numbers. We have 60 times 1.6 times 1,000, and then you could times it by 1 and 1, but what's the point? On the bottom we have 1, 1, 1, and 60 and 60, so 60 times 60. So again, try with your calculator. You can try 60 times 1.6 times 1,000 divided by 60, divide by 60 again. See if that works for you. Otherwise, you may have to get the product of the top first, which is 96,000, and the product of the bottom, which is 3,600. And then divide that. You should get 26.67 meters per second. Whew. And that is it. That is how we do some rate conversions using this table method. Go ahead and try some problems on your own. Good luck.